Good afternoon and thank you for joining us today. I'm Brianna, I'm the team lead for the LEGACI team. LEGACI stands for Lunar Engraver with Geologic Autonomous Carving Instrument. And here are the other students that make up the team and their respective roles in the design and business portions of the mission. The presentation will cover the main aspects of the mission before diving into the subsystem breakdowns and specifics about the business operations and business strategy. LEGACI's goal is to establish a profitable business venture utilizing the lunar surface by sending 2 rovers to the moon using CLIPS, the Commercial Lunar Payload Service. The rovers will have the ability to legibly carve into the lunar regolith using a robotic arm. Any adult can order an inscription to be carved into the lunar surface, and it can include words and/or simplistic pictures. The customers will receive a free digital copy of their completed inscription and a certificate of authenticity, with additional merchandise available for purchase. By purchasing an inscription on the lunar surface, customers can use LEGACI to give a thoughtful gift to a loved one, leave their family legacy on the lunar surface, or simply leave their mark on the moon. The mission has 5 years to go from Phase A to operations. A 15% margin was added to the schedule as a buffer. 5% was added as float time in between Phase A and Phase D. Phase D is split into 2 segments because Lockheed Martin, the company chosen from the CLIPS program, requires that we send them the payload 8 months prior to launch. The remaining 10% of the margin was added as a buffer in between the landing date and the January 2026 deadline. The Gantt chart also shows the business funding rounds and business tasks typically completed by startup companies. This will be discussed in further detail later. The system architecture for the mission was determined to be CLIPS, solar arrays, individual wheels, 5 cameras, and a robotic arm. Having 6 individually powered wheels offers increased mobility, adds redundancy, and reduces risk. 3 cameras are needed for standard operations, which is 2 for navigation and 1 for carving operations. However, it was deemed necessary to add at least 1 redundant camera to each system, which leads to 5 total cameras. And a 5 degree of freedom arm is needed to accomplish level etching, and 1 degree of freedom is needed for storage capabilities. This leads the robotic arm design to have a total of 6 degrees of freedom. There is ample research pertaining to robotic arms, which gives them a TRL status of 7. And CLIPS was chosen over buying a launch vehicle because CLIPS greatly reduces cost, complexity, and reduces risk because they take care of launch, landing, and payload deployment. Lockheed Martin was chosen as the CLIPS company for the mission because their lander was made specifically for rovers and had the largest payload area of all the other available CLIPS landers. Now here's Akshat, who will go over the ConOps for the mission.
Thank you, Brianna. So the payload user guide mentioned that Lockheed would make modifications to the lander to fit customer needs. And here you can see a before and after picture of the lander. The modification on the right is the dual rotor configuration that LEGACI would use for the mission. The Lockheed lander has cylindrical extrusions for payload mounting during all stages of flight to ensure the safety of the payload. The carving arm will be in its storage configuration to keep the arm safe when in transit to the moon, and the landing site that we chose was the northwestern rim of the Perry crater. We chose this site because it experiences 89% sunlight during the course of an Earth year, and also there are minimal ridges to negotiate, which minimizes the amount of possible shadows that be cast on the rovers. The rovers will move in a lawnmower pattern to maximize the number of orders completed, and the maximum distance in each column is 137 meters. This is based on the expected distance traveled per order and the expected number of orders per day. This also leaves a margin for when the rover has to navigate around small obstacles. You can see in the image here that the actual location of the landing site relative to the area that is going to be carved is quite small. And on the next slide, the time breakdown for the amount of time the rovers will be operating but not carving is shown. So lunar day is equal to 29.5 Earth days, and the time breakdown is as follows. For approximately 26 days, the rovers are operational, with 23 Earth days spent carving and 3 Earth days using communications and performing other operations. And in the remaining 3.5 Earth days, the rover will be in sleep mode. With 89% sunlight during the year, the rovers will have approximately 322 Earth days of sunlight. Of those 322 days, about 32 days is allocated to operations other than carving, and about 48 days is the maximum design limit. During the 32 days, the rover could be sending data, receiving updates, etc., that sort of thing. And with that, I'll hand it off to Rebecca for talking more about the business. Thank you.
Thanks, Akshat. Legacy's mission is to create a viable, profitable revenue stream for investors that ignites interest and investment in the consumer-based space market. Legacy's product is a carving system that provides customers with the opportunity to carve inscriptions onto the lunar surface. The flow of the business operations is shown. The customer will place their order, which gets sent to a ground station. The ground station will relay it to a satellite that will send the order to one of the rovers. One of the two rovers will then complete the order and send the picture of the completed order back to the ground station via the satellite. Once produced, the certificate and other merchandise will be mailed to the customer. On the company website, customers can enter the message they would like to have carved, receive an estimated time of completion, and pay for their order. Various merchandise and physical print options will also be available for additional purchase. Partnerships with a variety of companies will be required for the different functions of Legacy's business. First, a contract with MDA US Systems will be necessary to build and assemble the lunar rovers, as they had contracts with NASA's twin Mars exploration rovers, Spirit and Opportunity. Legacy will partner with the Swedish Space Corporation, which utilizes the Near-Earth network as they support recent lunar missions. Finally, partnerships with printing service Photomoto and artist shop Threadless will be necessary to handle the printing creation of all physical merchandise. Photomoto will handle all certificates of authenticity and photos ordered by the customers. Threadless will take care of all other merchandise orders. Since most business operations will be handled through contracted/partnered entities, minimal facilities will be necessary for development. Office space will be required for the company operation personnel and will house a mission control room to monitor the rovers. A business team and technical team will make up the company personnel. The business team will be divided into smaller subteams and will include marketing, human resources, operations, legal, and logistics. The technical team will be made up of expert subteams on rover development, rover maintenance, lunar regolith, research, path optimization, and etc. Now here's Justin with the communications budget.
Thanks, Rebecca. The Legacy Communications budget was completed following the guidelines from Design Heritage of both academia and a past partnership with the Swedish Space Corporation. These guidelines include the assumptions shown. The completed calculations for the communications budget estimate the number of images the rover is capable of sending and receiving per day. The number of orders per day will change, but this analysis will provide an effective upper bound for the technical capabilities of the rover. With an 8 megabit per second downlink bitrate, one rover could transmit 2,000 images within one 17-minute sustained connection with the Near-Earth network. With a 10 megabit per second uplink bitrate, the same rover would need an additional 40 minutes to receive 2,000 orders from the Near-Earth network. This leads to a time allocation of approximately 57 total minutes per Earth day to both transmit and receive 2,000 images, or orders. Legacy's operations requiring a finite amount of time instead of around-the-clock coverage, as well as the fact that the Swedish Space Corporation has supported previous private space ventures, validates sustained private use of the Near-Earth network. Therefore, this communications infrastructure meets the requirements of Legacy. An estimate of each subsystem allocation and a top-down mass estimate were made based on previous design heritage and recent lunar rover missions. 15% contingency per subsystem and a 20% margin were added. The primary driver behind mass sizing was the battery. The allocated mass of the rover is approximately 102.5 kilograms, with a design limit of 125 kilograms. This mass estimate is close to the mass of the Chinese rover U2, having a mass of 140 kilograms. And next, here's Jack, who will go over the thermal analysis.
Thanks, Justin. The most temperature-sensitive component on Legacy is the lithium-ion battery, which needs to be kept within a temperature range of 0 to 40 degrees Celsius to perform optimally, whereas lunar day and night can reach temperatures of negative 130 to 120 degrees Celsius. A single-node thermal analysis was conducted to ensure the rover survived the lunar thermal environment. The following equations were used to simulate the thermal environment. A list of assumptions are compiled as shown, and they define the values for equation 1, which drive the simulation. The graph shows the results of the simulation for one lunar day and night cycle, where the blue and red lines represent the upper and lower bounds of the battery's survivable temperature range. This graph shows intense overheating during the lunar day and freezing during the lunar night, as shown by the sharp decline. There are two modes of oscillation present in the graph. The first mode represents the variation of solar energy input on the rover as a result of shifting sun angles throughout the day. The second mode simulates the power variation expected throughout rover operations. This shows the need for radiators during the lunar day and a heating system for the lunar night. Based on the single-node thermal analysis performed, 70 watts of heating throughout the lunar night coupled with radiators during the lunar day will allow for the survival of the Legacy rovers through the lunar day-night cycles. This is depicted in the graph for when the thermal system is active. Industrial and commercial applications were used as a baseline to estimate power draw, as rover etching mechanism is novel. The power budget is shown, which uses conservative estimates. In order to size the batteries for the LEGACI rover, the different power modes were weighted to find the design point. Maintaining 70 watts of heating over a lunar night required the highest power storage, and became the design point. The total electrical storage required was found to be on the order of 5,000 watt-hours. From this, the battery specifications were found as shown. The power density of battery technology will only increase between the date of this report and construction. Thus, the battery estimates are reasonable for the mission. For power generation, the rover will rely on an array of ultra-triple junction solar cells providing 343 watts per square meter. A safety factor was added to account for the power modes when sizing the solar panels. There are 4 different power modes during rover operations. The first mode will consist of etching and camera usage, where the rover drivetrain will be idle as the inscription mechanism carves messages. The second mode consists of driving and camera navigation use. The third mode consists of communications, where the rover will sit idle while downlinking images of completed inscriptions, uplinking orders to be completed, and diagnostic data. The fourth mode is when the rover will remain in a hibernation-reduced power state during lunar nights, with minimal power being used to maintain vital components and thermal control. LEGACI employs a mount which contains 2 cameras and a LiDAR module that enables navigation capabilities. Dual camera computer vision is suitable for locating objects or craters and determining distancing. The solar arrays need to be able to face towards the sun at all times, so they are mounted on a 2 degrees of freedom gimbal. The final solar array design has a working area of 0.528 square meters, which meets the power requirements. The array is able to fold in half as shown for compactness and for the launch configuration. The communications dish is also fitted with a 2 degrees of freedom gimbal and will communicate with Earth to download instructions and upload pictures of completed orders. The dish has a 0.55 meter diameter parabolic dish with a surface efficiency of 0.5. LEGACI employs wheels with a radius of 15.24 centimeters and a width of 10.16 centimeters. The wheel radius is driven by the height of the platform on which the rover sits on the lunar lander, and the wheel radius is approximated from a variety of existing lunar rovers. 6 radiators were deemed necessary for the thermal system to avoid overheating during the lunar day. The camera for carving operations will be nearly identical to Perseverance's Mastcam Z and will be sourced from the original manufacturer, Mullen Space Science Systems. The Mastcam Z was chosen for carving operations since it has a high resolution and it has already gone through rigorous testing. In order to ensure the quality of these photos, small lights will be attached to the rear of the rover to illuminate engravings if the low elevation of the sun casts unfavorable shadows onto the engravings. The camera and lights are not depicted in the assembly. The final arm design has 6 degrees of freedom. The carving tip is relatively short since the rover will only carve 1 to 2 centimeters into the lunar surface, and it helps minimize structural strain. The robotic arm on each rover will be in the retracted position, tucked against the back of the rover during launch and landing to ensure that they stay safe. And now Justin will talk again with the carving experiment.
Thanks, Jack. Regolith particle size, regolith depth, and surface incident light were variables simulated on Earth in an experiment to validate the intuition that legible carving can be done on the surface of the moon. The first trial focused on scale, legibility, and feasibility. The lunar regolith was modeled using a mixture of 99.9% cornstarch and 0.1% carbon black powder with an average particle size of 15 and 30 micrometers respectively, which is similar to the lunar regolith. The lunar regolith held its shape, the low lighting angle of 5 degrees provided sufficient contrast, and the carving was legible at a size feasible for the rover to replicate. The second experiment investigated different carving tips, minimum legible font height, and maximum line density. A large angle aluminum cone, small angle aluminum cone, and rounded plastic tip were chosen for further analysis. The maximum line density for each tip was found by progressively making closer and closer striations until the mark was indistinguishable, and each carving tip was used to write letters of various sizes. These trials led to the thin, small-angle aluminum cone as the tip of choice. The maximum line density for the small-angle aluminum cone was determined to be roughly a half centimeter. In addition, the smallest legible font detected by a camera was approximately 1.3 centimeters. Given that the moon's gravity is 1/6 Earth's gravity, any particulate matter will hold shape better on the moon than on Earth and will be even more distinguishable. And next, here's David, who will go over the product details.
So customers will pay $9.99 per second the rover spins to carve their desired inscription. The robotic arm can be programmed to move in a complex manner, allowing the rovers to carve in multiple languages as well as carve simplistic images. The customer can do a mix of words and images as shown. A similar market base is that of people who get tattoos. Average to high-end tattoos can range from $250 to $800. This, coupled with the fact that 4 out of 10 US adults have a tattoo, means that there will be an ample market base for the legacy business. So the average number of orders completed per day by the two rovers was calculated at 2,568, which leads to approximately over 800,000 orders completed per year, with the average order costing $500 to $600. The average number of orders per day was based on the slowest average speed of a 3D printer, being approximately 50 millimeters per second. In order for the legacy rovers to meet the expected number of orders per year, only 0.015% of the world population over 18 is needed in order inscription per year. For the ordering process, the customer can enter the inscription on the legacy website. Then a price will be generated based on the expected time when the rovers would spend inscribing it. Submissions are limited to one inscription per week, which would be enforced using the customer's email address. And the request would then be either approved or denied. If the submission is approved, the customers will be notified whether the request is either an original or a duplicate. If it is an original, then the customer can go ahead and place the order. If it is a duplicate, the customer can choose to buy the duplicate for a discounted price or place the order and have one of the rovers reinscribe it. Having this option to buy the duplicate saves the rovers time by not re-etching the same inscriptions. It also enables more original inscriptions to be carved, which would boost revenue. If the submission is denied, the customer will be sent a reason for the denial, and the customer can then redo their inscription and resubmit it a week later. After the customer has successfully placed their order, they can buy additional merchandise. The customer will receive a free digital picture of their completed inscription as well as a certificate of authenticity. The customer may then purchase physical copies of their inscription, which Photomoto will fulfill. Daedalus will also fulfill all other merchandise orders where customers can have their inscription printed on a wide variety of items, including shirts, jackets, phone cases, and a lot more. At the beginning of the order process, the list of censorship that Legacy enforces will be shown, including no profane language, no racist statements, and no lewd pictures. Existing legal precedent protects Legacy's right to censorship. Legacy also retains the right to censor anything in addition to the list above at Legacy's discretion. Before the customer can place their order for their inscription, they must agree to a legal disclaimer. This legal statement will have the customers acknowledge the list below. Legacy cannot guarantee the longevity of the completed inscription. Resale of inscription photos is prohibited. The customer cannot get a refund unless the rover does not complete the order. The customer does not own the area on the moon that their inscription was carved on. The no refund policy applies to the customer's purchase on their inscription as well as any additional merchandise they purchase. Now here's Ali with cost estimation.
Thanks, David. The initial cost estimate for developing and operating the Legacy rovers was based on the mission cost of the Opportunity rover. This is likely an overestimate since the Opportunity rover had a far greater mass than many scientific instruments. Employee salaries are estimates based on current average salaries, and the cost for launch is based on the price listed by Lockheed Martin, which is $1 million per kilogram of payload. The marketing cost per year was based on the rule of thumb that a company spends close to 10% of their yearly revenue on marketing. The second wave of rovers will be built after the first wave is operational. Legacy will not start to acquire revenue until halfway through 2025. Revenue is expected to increase in the last year of the operations phase, 2030, when the second wave of rovers will have a slight overlap with the first wave. This graph is a cumulative summary of the cost and revenue graphs shown previously, as well as a resulting profit estimate. It is estimated that the profit of the mission after 5 years of operation will be approximately $2.3 billion. An EBITDA analysis generates a projection of revenue and cost estimates, and is summarized as an income statement here for years 2025 through 2030. The cost of goods and services is an approximate cost of operating the rover over its lifetime, and it also includes fees associated with creating merchandise and sending pictures to customers. The depreciation expense linearly spreads the value of the rovers, $160 million per rover, over 5 years of use. The SG&A expenses stem primarily from marketing and facility costs. This expense is highest in 2025 because the cost of launch is absorbed into this category. Tax and interest expenses are estimated due to the vague nature of space business finance, so the tax rate is simply set at 21%, which is the current U.S. corporate tax rate. The NASA Project Cost Estimating Capability tool assists in determining the cost of the mission using historical data and cost relationships. These variables include the number of payload elements, the experience of subsystem manufacturers, the approximate radiation environment of the rovers, and many more. Each category includes fees and burden charges of 10%. A 20% reserve was also applied, increasing the total estimated cost for development and operation of the rovers to about $378 million. Note that the estimated launch service cost is $85 million, and when this value is subtracted from the total, because the tool's historic data does not include clips as an option, the total cost decreases to $275 million. Our independent cost estimate, excluding launch service, is approximately $300 million. The relatively small difference between these values supports our independent estimate thus far. $300 million will remain the approximate cost of the mission and will act as a margin in case costs are higher than expected. Now, Rebecca will discuss the Monte Carlo simulation.
Thanks, Ali. Monte Carlo simulations were used to predict the expected profit over the course of the mission from 2021 to 2030. In this study, the revenue streams of the mission were combined and estimated in a single normal distribution for each year. The figure displays an example of a distribution from the study, and the standard deviation for each distribution used was 30% of the mean value. This significant value provides ample room for the revenue streams to be higher or lower than expected. The variables for the simulation were cost and revenue inputs, which were determined using the NASA PCAC tool and the EBITDA analysis. After estimating the revenue as a distribution, the estimated expenses for each year were subtracted from the revenue to create a distribution estimating profit for each year. Note that the profit region expands because the revenue begins growing in volume. The yellow line specifies the mean estimate, and the red and green regions delineate the first and second deviation regions. The lower bound of the second deviation for the cumulative profit estimation is depicted to be approximately $2.4 billion by the end of 2030, which aligns with our estimates in the prior section. This indicates that the business is predicted to make a minimum of $2.4 billion by 2020, but is likely to make more than that based on the results of the simulation. Here's Kevin with the risk analysis.
Almost 24 principal mission-specific risks have been identified. R corresponds to a research mitigation approach, and A corresponds to a risk that has yet to be accepted. The goal in choosing the rover hardware was to select highly robust, proven technology, TRL 7 through 9. Adding redundancies to the mission and the rover was done to mitigate the risks mentioned above. These redundancies include having each wheel of the rover be powered separately and sending multiple rovers up to the moon. By doing this, the mission takes on as little risk as possible and provides the surest path to full mission success. Several of the business risks involve the difficulty of evaluating interest, cost, and public perception of the project. LEGACI relies on public interest and accurate cost estimation to achieve profitability. Market size was put into perspective in a prior section, which is approximately 0.015% of the total market. Post-product launch, those concerns of the market size will decrease nearly to zero. There are also legal implications of writing various texts on the lunar surface. According to current space law, the Outer Space Treaty of 1967 states that no one can own land on the moon, which justifies the waiver customers have to sign, recognizing that they do not actually own a portion of the moon. Another space law concerns the Moon Treaty of 1984, which prohibits the use of space or celestial bodies for a profit. However, this treaty is not ratified by all of the main space exploration countries, so it does not bear significant consequences on the mission. People may also try to make the argument that LEGACI is graffitiing the moon. To stifle this, a percentage comparison between the moon and the total area used by the mission was calculated. The surface area of the moon is approximately 38 million kilometers squared, and the max total area used by 2 rovers for 5 years is 1 kilometer squared. That is 2.84 times 10 to the negative 6% of the moon's surface. Other risks include MMOD impact, both for the rover and for the etchings. The MMOD probability of impact model is used for impacts of particles less than 1 gram. The results show that the probability of a customer's etching being disturbed by MMOD is minuscule but not zero. The same is true regarding an MMOD impact one of the rovers. In addition, the North Pole of the Moon is a highly popular region, and many countries are interested in launching missions to the North Pole of the Moon. Customers are made aware of the semi-permanence of the etchings due to this high interest in the North Pole of the Moon, given that some previous areas of etching may be traversed. There is some risk involved in this, swaying people to choose not to place an order, but it is small. And here's Nader with the business strategy.
Thanks, Kevin. On the business strategy, the financial quarter schedule used to organize corporate tasks follows the NASA nomenclature, with a fiscal year beginning in October and ending the following September, with quarters named Q1, Q2, Q3, and Q4. Initial financing will consist of seed funding and any loans needed to provide support. We then expect the Series A, B, and C funding rounds to finance developmental and operational costs from Q4 2023 through Q1 2031. Legacy will need to identify stakeholders to support business operations. Prime candidates would be suppliers of liquid or material capital. The next priority will be to coordinate with the design team to define the carving and data transmitting capabilities of the rovers, then acquire facilities to house project development. Together, these three tasks will last from Q2 2021 to Q3 2023. The company will then need to begin developing the website and marketing campaign to garner interest from the public. Post-launch, public interest will be assessed to see if expansion is still viable long-term, with a decision expected in Q1 2027. At that point, the marketing campaign will be adjusted to fit changes in the target demographics. Beginning in Q1 2030, market research will be conducted to determine an appropriate cutoff date for orders. This will allow the rovers to complete all orders before end-of-life operations and prevent a backlog. This will be done incrementally by region, with an announcement expected in early Q3 2030. Meanwhile, the marketing campaign will operate on two fronts, consumer and corporate. Consumer marketing will leverage social media alongside cable and streaming services to garner interest among the general public. The plan is to use pre- and post-launch intrigue to achieve viral marketing status on Facebook, Twitter, Instagram, and other social media avenues. As part of this, pay-per-click advertisements will be placed on these platforms. An example ad is shown. Additionally, corporate marketing will use newspapers and magazines such as Popular Science, Popular Mechanics, and Bloomberg Businessweek to advertise directly to businesses, with an estimated cost ranging from $20,000 to $40,000 per half-page ad. One more avenue Legacy can explore is allowing corporations to use their own Legacy inscriptions for their own advertising campaigns. And the longevity of this approach could create a market for an entirely new form of advertising. Regarding exit strategy, Legacy has three options: expansion, downsizing, and sale. Expansion is currently the expected option for 2030 and involves sending a second wave of rovers to relieve the first pair. However, if investors decide against this, the alternatives are designed to maximize potential gains. Downsizing operations minimizes expenses and enables leadership to offer remaining shares for a buyout. Meanwhile, a corporate sale is intended to recoup investor losses with an influx of liquid capital. Potential customers would be government or commercial entities interested in lunar-focused R&D. To recap, Legacy offers shareholders an opportunity to invest in a novel and innovative idea in an untapped market. Legacy's approach to a cis-lunar corporate model minimizes resources and maintains scalability. Using Clips reduces launch and development costs as well as business risks, while sending two rovers sustains business viability in the event of rover failure. Using flight-proven technology such as robotic arms, Legacy repurposes previous design heritage in the pursuit of innovation. This mission will leverage this design heritage, as the robotic arms on the rovers will be used to carve into the lunar regolith for practical applications. The Legacy mission offers all people of the world a chance to leave their legacy in the stars. LEGACI is a novel concept for corporate use of the moon and could inspire growth in the commercial space enterprise. And on top of this, the mission provides a template from which future cislunar corporate development efforts can draw crucial insight. Thank you all for your attention. The LEGACI team appreciates you watching our video.